So I was going to say welcome to the 2023 induction ceremony for Sigma Zeta, which is the National Undergraduate Honor Society established to encourage and foster scholarly activity and to recognize academic scholarship in the natural and computer sciences and in mathematics. So I'm Professor Karen Wendling. I'm a chemistry professor and the chair for the Center of Natural and Behavioral Sciences. And my colleague, esteemed Dr. K, chair of biology. We will be running technically it's a ritual, an initiation ceremony. To get the wand out, yes. Though I will say there was a misconception in previous years. This is not a secret society. This is a very public, affirming society in support of the natural sciences and computer sciences and mathematics. So before we get to the ceremony itself, I'd like to introduce our speaker for today, who is Dr. Patrick McCauley. He's a professor of religious studies and philosophy here. He has his PhD from the University of Iowa in philosophical theology and literature. And he teaches a number of courses here on campus that are incredibly popular. I will say I have a few of my advisees that are minoring in philosophy and religious studies because they told me they'd like to take more courses with Dr. McCauley. So things like Introduction to Philosophy, Philosophical Thinking, Fundamental Moral Theology, and you may not be aware, because he hasn't taught it here, but he's taught it in other colleges, Science and Religion, or Science and Philosophy. And that's actually why I asked him to come and speak to us today, right, as our special guest speaker for this event, because scientists, which we all are here, right, maybe not a couple of parents, but all of the students and faculty here are, to some extent, are scientists. And we oftentimes, or I'll speak for myself, oftentimes I'm so focused on learning the science and like doing the lab experiment, getting through it, making it happen, that I'm not always thinking about the consequences of my actions. And you might say, well, wait a minute, Dr. Wendling, you're a college professor. Like, what could really go wrong? Well, this isn't a story I tell often because it's a little embarrassing. But a few years ago, late at night, I was prepping a lab, and it was very simple. I was just making a dilution. I took some liquid of one chemical and I needed to add water to get it to be at a lower concentration. Fortunately, I was wearing gloves, goggles, and I was in a hood. Poured in some water, like, and it geysered up, like, towards the ceiling inside of the hood. And I did this, like, oh yeah, that's exothermic. That's an exothermic reaction. I would have known that if you'd asked me that question on a test, but I was so in the moment of getting ready for lab that, I created a geyser, which I cleaned it up, it was okay. But the point remains, sometimes we get so focused on what we're learning and what we're doing that we forget to think of the greater meaning and the reason why, and also the consequences of our science. And it was for that reason that I invited Dr. McCauley to speak to us briefly here today. So let's give him a little welcome. All right. Well, we had a lot more chairs needed than what I would have expected, so we're good.
All right. Usually I say questions, thoughts, ideas, concerns, but today not. Judgment. Judgment is accomplished through the application of rules. Judgments such as this coffee is too hot, or that dress is pretty, or what you just said is inappropriate, or Russia's invasion into Ukraine is unjust, or the particle accelerator at CERN is worth what it costs, or the CDC is a reliable source of medical information, or that shirt is purple, I meant eggplant. These are all judgments. The common temperature of hot coffee is between 195 and 205 degrees Fahrenheit. The wavelength of purple is around 380 nanometers. If most people enjoy coffee at around 200 degrees F, then that temperature, 200 degrees F, serves as the rule, or the measure, of what hot or cold coffee is, and how it's determined. Coffee that is at 210 degrees F is therefore too hot, as it is greater than the temperature that serves as the rule. Light of the wavelength of 380 nanometers is defined as purple. When my eye perceives purple, it is assessing that particular light experience as 380, give or take, nanometers, even if we don't know it. The color purple, or 380 nanometers in wavelength, the same thing, is the rule for judging light as purple. Where there is a judgment, a rule or a principle has been applied. However, we are so good at the application of principles for the sake of judgment that we don't commonly notice that we are doing it. If I look at my friend's cool new jacket and say, hey, that's a cool new jacket, I might not even be able to tell what principle of cool I have applied to the judgment of the jacket, even if I am very sure that the jacket is cool. What is the principle of cool jackets anyway? Sigma Zeta is an honor society dedicated to the study of mathematics and science. So we must ask about the principle or the rules that govern and guide scientific inquiry. What is the principle by which we judge something scientific? What makes something scientific? Well, Francis Bacon was one of the first to ask this question, and he suggested that the scientist should be concerned with, quote, disclosing the secrets of nature. For the scientist, quote, the inquisition of the truth is his sole object. Do you agree? Do you think that science should be guided by the principle of discovering what there is to discover of the natural world and universe? Isn't this the principle that undergirds the scientific method? I myself, at least am, for the time being anyway, persuaded. I do think that science is tasked with the duty to try and discover all there is to find within the intricacies and majesties of the natural world. I, for one, benefit daily from these kinds of discoveries. The question we must next ask is this. Is the thoroughgoing inquiry into the secrets of the material world the one and only principle of scientific pursuit, or are there more? Should this rule of judgment be given free and unfettered rein, or should there be restrictions, limitations, amendments? Einstein delved into the relationship between mass and energy, and soon there were nuclear weapons dropping on Japanese civilians. I'm not being judgmental just yet. Are you? Was Einstein a good scientist? Did he discover good natural world secrets? Did he discover some of what there was to be discovered when others could not? I'm not being judgmental just yet, because in order to be judgmental, we would need, as I'm sure you've already surmised, a principle, a rule. There can be no question that according to Bacon's principle, the principle to discover what there is to discover of the natural world, Einstein was deserving of his Nobel Prize. However, that principle does not seem capable of taking those dead Japanese civilians into account. Again, I'm not being judgmental, because I would need a principle, a rule to do so. And one would have, and the one we have placed on the pedestal, the inquiry into the nature of the natural world, does not seem prepared to offer commentary on these dead Japanese. Some scientists think that we should experiment with animals, and others think we should not. The scientific principle, the principle that calls us to unearth all there is to unearth, would guide us to use any and all possible experiments to yield new findings, for, as Bacon suggested, quote, the inquisition into the truth should be the scientist's sole object, unquote. If this principle were the only principle in play, there would not, it seems, be any debate on the issue. If discovering natural secrets was all that mattered, then suffering animals would not arise as a concern. I once had the great pleasure of having dinner with Eva Kor. As a 10-year-old, she had been a research subject of Dr. Joseph Mengele, a German medical researcher who performed experiments on captured Jews in the concentration camps of the Nazis. Mengele has gone down in history as a monster of the highest order. Eva gave a moving speech that night about the heroism of forgiveness. It was an honor to hear it. She has since passed away, but you can hear her, if you wish, on YouTube. So here's the hard question. Was Mengele a bad scientist? Was he a bad person? What if these two inquiries require different rules of judgment, different principles? Immanuel Kant was a German-speaking Prussian philosopher who died in 1804. He is one of the world's most famous and influential members of the philosophical tradition. In his second most famous book, The Critique of Pure Practical Reason, Kant discussed the connection between pure reason and individual morality. At the core of this work, Kant discusses what he calls the categorical or the unconditional imperative. It is a rule. The categorical imperative is a principle, but how does it work? Well, Kant, being a good and honest member of the Enlightenment, was very suspicious of superstition, and as a result, he leaned heavily on the certainty and reliability of reason. Kant preferred the self-evident reliability of mathematics, for example, over the often unsupported assurances of religion and governmental authorities. A pope can turn out to be mistaken, while mathematics, well, usually not. That 1 + 1 = 2 is reliable in a way that the assertions of an authority figure can never be. 1 + 1 = 2, and I don't have to take anyone's word for it. That is why, for example, Jefferson and Franklin used the phrase self-evident in the Declaration of Independence. So what was Kant's principle? Well, it starts with free will. Kant argued that as human beings, we find ourselves the authors of our choices. We make up our own minds as to what we will do. I can decide to eat or forego the cheesecake. Further, we have discretion as to the reasons or motives of our actions. Not only will I decide what I will do, I will also decide why I will do it. If I see myself as the author of my decisions, I will also see that I am responsible for these decisions as well. Freedom and responsibility are really two sides of the same coin. At least that's what Kant thought. If someone else were controlling my choices, then that other person could be held responsible for them. If I believe I am not being controlled, then I also believe that I am the one who's making my decisions. However, in that very moment I begin to perceive my own free will, I will, in that very moment, presuppose the same individual free will in all other human beings I come across. He then reintroduces the certainty of pure mathematical reason. He reminds us of the obvious and self-evident certainty of a mathematical phrase like 1 = 1. We can see for ourselves that 1 can neither be greater than nor less than 1. He reminds us that no imposed authority of religion, no government or brutal high school clique could ever shake the certainty of this statement, because rational creatures have no capacity to doubt that which is of self-evident certainty rational. 1 must equal 1, no matter who claims that it doesn't. He then makes his pivotal move. As physical creatures, we're all different in innumerable ways. Different hair, different height, different family backgrounds, and on and on. However, free will is identical in everyone in all of its instances. My free will is the same as yours is. Free will does not have a skin color or gender. It is identical in all its instances. We are each one person, one bearer of free will. So just as 1 = 1 in mathematics, it must also do so in subjective rational morality. Kant is saying here that our own minds, our own subjective selves, come to discover a rational certainty that we are obviously and self-evidently of equal importance. It is our own rational minds that tell us this, not Kant's rational mind. The discovery of universal human equality and its rational self-evidence, he said, must be discovered by each individual person individually and subjectively. And then, he said, we have the choice to employ this awareness as the rule, as the principle, as the subjectively selected motive of our own free choices and actions. Failure to do so, and my own reason, will hold me accountable for irrational or hypocritical motives. These irrational motives then give way to indefensible actions, for 1 can never be greater nor less than 1. I suspect that most of you caught the return to rule and principle in the last few lines. We recall that where there is a judgment, there must be a rule and a principle by which judgment is performed. Science must indeed be dedicated to its principle of unbounded natural discovery, and this must be the right way to think about science. But science is not a person. It is a field of inquiry and a tradition. Kant argued that humans bear with them a self-discovered certainty of universal human equality, and they bear it as a self-evident certainty. I'll read that again. Kant argued that human beings bear with them a self-discovered certainty of the universal human equality, and they bear it as a self-evident certainty. According to Kant, we find that sexism is immoral because it violates the 1=1. We find that racism is immoral because it is irrational. It violates the 1=1 principle. We find that oppression is immoral because it violates the self-evident, subjectively discovered certainty that all humans appear to me as of equal value. It is this that Mengele forgot. It is by means of this principle that he is judged. Science probably should be guided by its principle of discovery. However, I am hoping that you are beginning to see that science will not, on its own, bring boundaries and limitations to its own inquiries. What science cannot do must be left in the hands of the scientist, the human being who performs the noble and crucial work of science. Science is hard, it is demanding. Those of you here today being honored will have already come to discover that real science requires a very serious and exacting commitment and dedication if it is to produce relevant results. This determination can threaten us, tempt us to disregard all other principles as we surge forth, like Dr. Frankenstein, in the spirit of discovery. So as you move forward from your education into your careers, you must remember that whatever limitations, whatever bounding principles of judgment science is held to, will have to be brought to it by the human scientist, him or herself. This is the last paragraph. My father is a world-important scientist who has just recently retired from his career that ended with the invention of bulletproof materials that can be sewn into a soldier's uniform. In his career, he learned the hard way that scientific inquiry does not provide its own limiting principles. During the last decades of his career, he wore a steel ring that stood as a symbol of his membership in a society of moral scientists. I asked him why he felt the need to wear that ring with the same consistency that he wore his wedding ring. He told me that it was his own responsibility to bring his moral principles into the lab with him, and that he wore that ring because he needed that reminder every day. Thank you.
Especially for taking the time to, as you might have heard, a little bit of dinging happening from, I think it was your cell phone. He is a husband and father of 2, including a senior high school student who's getting ready to go to college. So I bet you
this is the one that's being picked up from a tennis match.
And I did have a little bit of a thank you gift for you, partly because I know you are gluten-free and the reception is just packed with gluten. So this is gluten-free.
And just a little bit Irish.
Yeah, just because his name is Patrick doesn't necessarily mean that.
Yeah, but my birthday on St. Patrick's Day does
Thank
point
you.
that direction.
Well, but I think you're absolutely right. There's nothing inherent to the pursuit and the practice of science that limits it, that asks us the question of should we be doing this experiment, or can this result be used in a way that we don't expect? No. So you may have noticed that we are here in the library on the 2nd floor, and this is the Irish room, which has a really fantastic recognized holdings of Irish literature. You might have said, Dr. Wendling, why did you pick this room? So we opened the windows, it was really warm. It's a little bit dusty in places, and you can see the decaying film on the windows is giving some very interesting background noise. The reason why I picked this room was because I did not want to do this in a classroom. I wanted to do this surrounded by literature, surrounded by the work, the learning, the sharing of everyone that has come before us. I think it was Einstein that said, I've seen far because I stand on the shoulders of giants, right? All of us could not get science to the place that it is now if we had to start from the beginning. So that's why I chose this venue, despite a little bit of a couple of minor issues. So with that being said, I'm going to call up Professor Kulkowski, and we will go into the initiation ritual that's part of today's induction ceremony. So Professor Kulkowski and members of the Gamma Alpha chapter, which is the Chestnut Hill chapter of Sigma Zeta, it is an honor to present these candidates for initiation as active members of our chapter. And as your name is called, I'm going to actually ask that you come up and stand. I think we can fit about half of you on this side and half of you on this side in a line here, so we can see who is being inducted. Yep. I had to add more chairs. Yeah. All right. So first, these are in alphabetical order. So Kayla Bowers. Yay. Jackie Koval. Aubrey Elias, Javon Felix, Michaela Grimes, you can come over here, Michaela, and I know Samuel Hallett couldn't be here today. Jay Coleman, and Allison Isaac, Dong Nguyen. Yep. I hope so. Yeah. Francis Vassallo. And Sydney Watts. There we go. Alrighty.
Okay,
We made it.
My turn.
Yes.
It is indeed a pleasure to welcome you. Your achievements in scholarship and interest in science make you eligible for membership in this chapter. Our society has two major purposes. First, the encouragement of scholarship in science, and second, the recognition of creditable attainments in this field. Wow, that's big. As active members of this society, you will be expected to work toward the fulfillment of these aims.
Before presenting you with the certificate of membership in our society, I would call your attention to the symbols which appear on the key, which is here in the yellow. It's also going to be on your certificate itself. This is a key, right? The key itself symbolizes your opportunity to unlock the doors which lead to truth. The form of the key seems to suggest the open book of nature, the source of all scientific learning. A book is open to indicate that no knowledge is closed to anyone who diligently seeks it. The closed books, which are shown kind of within the open book, right? The closed books represent accumulated scientific knowledge to be studied as a record of the past and as a guide to the future. The 3 volumes standing together illustrate the division of science into the life sciences, the earth sciences, and the physical sciences. The 4th volume, supporting the others, is symbolic of mathematics, the foundation and basis of science. The retort and tripod, which are on the left-hand side, are symbols of an ancient process by which pure substances were separated from their impurities. This is giving indication to chemistry's history in pre-science in alchemy. Yep. To us, they typify the experimental methods in our various fields. The flame used to heat the retort represents the motivating forces of science that direct and inspire scientific achievement. Also, the books and retort stand for 2 great sources of scientific advancement. First, a study and knowledge of humankind's accomplishments up to this time, and second, further experimentation with sources of new truth, which we could have had Macaulay up here to talk about that one as well. The Greek letters sigma and zeta designate both the society and its motto: seek diligently together for truth.
And now it's my great pleasure to present the certificate of membership and welcome you as active members of the chapter of Sigma Zeta. You are now entitled to all the privileges of active membership in this society. Congratulations.
Yep. Alright, so let's go down the
Hand them
line.
out. Ayla,
Thank you.
congratulations. Jacqueline, congratulations. Aubrey, congratulations. Javon, very good, excellent. Congratulations. Michaela, you look good, this is good.
And the next one,
Congratulations.
Sam is not here. Yep.
And Sam is not here, so we'll put him in the back. Jake, congratulations.
Don't stop him.
He's a dropout.
No.
Allison, good to see you again, Allison. Congratulations. Zoom,
Thank you.
put your real name on that.
And Brianna's not here either. Yep.
And Brianna is not here, and Francis. Excellent. Congratulations. And Sydney, congratulations.
Let's give them one more round of applause. Yep. And as I say, I did not mark it down, but I know we think we might have a couple seniors here as well. But even if you are not a senior, if your time is coming, the center provides the golden Sigma Zeta medallion for you to wear with your robes on graduation day. We make a big deal of handing this out kind of in the hooding ceremony right before you go walking to graduate. So you can look forward to the Sigma Zeta medallion to show your membership in this society. So thank you all, and our formal ceremony has now concluded. But we do encourage you to introduce yourselves to anyone you don't know, including a lot of friends and family who are visiting today. And to our new inductees, congratulations on your achievement. We look forward to your continued excellent work here at Chestnut Hill College and beyond. Yep. So behind